So we have a 1,785 kilogram car rear-ending a smaller compact car. Then they stick together, and you're asked how far does the wreckage move after the collision. We don't ask what direction because these two cars were traveling in the same direction, so it's fairly obvious that the wreckage will continue in that same direction. That's why in this case you're only asked for the speed. The law of conservation of momentum tells us that the momentum before is equal to the momentum after. So in this case, we have two cars, and I'm going to call this car A and this car B, and their momentum before, so PA1, momentum of object A at the beginning, plus PB1 equals the momentum after. But afterwards, they stick together. So instead of two objects, we have one object, AB. So we know that the mass of A is equal to 1,785 kilograms, and the initial velocity, velocity 1 of A, is equal to 25 meters per second, which means that we can get PA1 by doing mass times velocity, and we will get 44,625 kilogram times meters per second. And our mass of B, and we don't have to say 1 or 2 because the mass doesn't change for this individual object. And the velocity of object B at the beginning was 19 meters per second. And we can solve for the momentum by doing mass times velocity. We'll get 21,375 kilogram times meters per second. We can add these two momentums up in order to find our final momentum of the wreckage. So the momentum of object A and B when they're together at the end is 66,000 kilogram times meters per second. However, we're not asked to find the momentum, we're asked for velocity. So we need to know our mass of A and B. What is our mass when they become one nasty wreckage of an object? So we'll just do 1,785 plus 1,125 gives us 2,910 kilograms. And so we say, we know P equals M times V, so V is P divided by M. So our velocity is our final momentum divided by our mass. We just have to make sure that we use the correct mass. And when we round to two significant figures, we get 23 meters per second.